Okay, so we are going to go through exercise 5D, which is all about like terms. What are our learning intentions? To know what like terms are, to be able to identify like terms within an expression, and to be able to simplify expressions by combining like terms. So let's start off with a bit of a starting activity. What we've been asked to do here is simplify by combining like terms. And this first one on the left hand side here, as you can see, it looks like we've been to the supermarket and we have 2 apples, 3 bananas, 3 apples, and 5 bananas. If we were to simplify by combining like terms, what do you think this phrase means, combining like terms? Well, if I have 2 apples and 3 apples, why not just write I have 5 apples? And I'm going to try to draw an apple. There it is. And instead of saying I have 3 bananas plus 5 bananas, why don't I just say I have 8 bananas? Doesn't it make sense to combine together the things that are the same? So I'm combining like terms. These are like terms, and these are like terms. So instead of saying I have 3 bananas plus 5 bananas, I'm simply saying I have 8 bananas. Instead of saying I have 2 apples plus 3 apples, I'm simply saying I have 5 apples. So let's come over here and do the same thing. The only thing that makes this different is I'm now dealing with pronumerals. So if I have 2x and I have plus 3x, that means I have a total of 5x. And if I have 3y plus 5y, that means I have a total of 8y. I have simplified this by combining like terms. Let's now move on to our first example, which is asking us to identify like terms. So here's the definition. Like terms are terms containing exactly the same pronumerals. Exactly the same pronumerals, although not necessarily in the same order. So 5a and 5ab and 3ab are like terms. 4a and 7b are not like terms because a and b are different. 2acb and 4bac are like terms, and the reason why they're like terms is because they contain exactly the same pronumerals, even though they're not in the same order. What really matters for like terms is that they're exactly the same pronumerals. They don't have to be in the same order. Okay, so let us see if we can answer this. Classify the following pairs as like terms or not like terms. 3x and 2x. They are like terms, and the reason why they're like terms is because they both have x. Let's go to the next one. 3a and 3b. 3a and 3b. Well, these are not like terms because a and b are not the same. What about 2ab and 5ba? Well, these are like terms. They contain exactly the same pronumerals. They're just in different order. What about 4k and k? These are like terms. They both contain k. And we should know that this has a coefficient of 1, but we don't write that in when the coefficient is 1. Next, 2a and 4ab. These are not like terms. And the reason they're not like terms is because they don't have exactly the same pronumerals. This has a and this has ab. They're different. What about this? 7ab and 9aba. These are not like terms because this has ab, but this is aba. They're not exactly the same pronumerals. All right, let's now move on to our second example, which is all about collecting like terms. So like terms can be combined within an expression to create a simpler expression that is equivalent. For example, 4ab plus 3ab can be simplified to 8ab. If 2 terms are not like terms, such as 4x and 5y, they can still be added to an expression like 4x plus 5y, but this expression cannot be simplified further. The sign in front of the term stays with the term even when it's moved. This is a very important line, and we're going to be seeing how that gets involved very soon. All right. So we need to simplify the following by collecting like terms. So first, let's collect our like terms. Well, for this one, I have 7b and I have 3b. Both of those are like terms, and this 2b is not a like term. Now, what's really important is that we include the sign in front of the term, and that's what this says. The sign in front of the term stays with the term even when it's moved. So if I was to rewrite this right here, so my like terms are next to each other, it's going to be 7b plus 3b plus 2. So what I've just done there is I've moved it. So all my like terms are next to each other, and then my constant here is by itself. So that means altogether, what I have is 10b plus 2, and that is my answer. All right, let's come to our next one now, and again, let's collect our like terms. So I have 8a, and over here I have plus a, so see how I'm highlighting the term in front of it. Then I have plus 2b and plus 3b. So if I was to rewrite this so all my like terms are next to each other, I have 8a plus 2b plus 3b. So that means I have this and I have this right here. So now let me combine them. So this is going to be 9a, and over here it's going to be 5b, because 8 plus 1 is 9 and 2 plus 3 is 5. Okay, let's keep on going now, and let's see, let me put a box around this, if we can go a bit faster. All right, so I have 2a. I do not have any other a's here, so that means 2a stays by itself. There's nothing else to combine that with. I have 2b, but there is nothing else with b here. There are no like terms for b, so that 2b stays by itself. I also have 9, and I have 3. Those constants can be combined together. 9 plus 3 is going to be 12. So that would be my answer. So not many like terms there for me to collect. What about this one? Here I have 12ax, and I have ax, and I have 9ax. So I have 3 like terms here. I could add all those together. So I know ax plus 9ax, that's going to be 10ax, plus 12ax, that's going to be 22ax. And then I also have 2a and a, so that's going to be 3a, and I also have 7b here. So it's going to be plus 7b, no like terms for the b. So that is going to be my answer for that one. So as you can see, if you are feeling confident, you can go straight for the answer. So I'm going straight for the answer there. Or if you need to, you can do that extra step and trying to rearrange them so it's a bit easier for you to collect the like terms. Okay, let's keep on moving. Here it says, simplify the following by collecting like terms. So we're doing the same thing here again, and I've repeated this line. It says the sign in front of the term stays with the term even when it's moved. So that's going to become very relevant now when we have minuses. So I have 13a, I have plus 2a, and I have minus 4a. And now let's collect the like terms for the b. I have plus 8b and minus 5b. If I was to now write them so they're next to each other, I have 13a plus 2a minus 4a, then plus 8b minus 5b. So what I really want you to take a note of here is the fact that I have moved the sign in front of each term. The sign is important because the sign is going to tell me whether I'm going to add or subtract. So right here, as you can see, I took 13a from here. I took plus 2a. I took the whole thing, plus 2a, and I brought it there. And I took minus 4a, and I brought it there. And then the same too with the other side here. It's really important that you include the sign in front. So now when I'm adding this together, I'm going to get 13a plus 2a is 15a, minus 4a is going to be 11a. And then on this side, I'm going to get 8b minus 5b, which is going to be 3b. And that is going to be my answer. Let's now go on to the next one. Let's see if we can figure out if we have any like terms here. Well, I've got a constant of 5, a constant of negative 2, and a constant of plus 12. And then this plus 4b and minus 3a, they don't have anything, but I will still highlight them. So that doesn't have a like term. And then my other one as well, this one doesn't have a like term either. So what does this mean? Let me just take this 5. So 5, I've got minus 2, I've got plus 12. Then I've got plus 4b, and I've got minus 3a. 5 minus 2 plus 12. Well, minus 2 plus 12 is 10. 10 plus 5 is going to be 15. Then I'm going to get plus 4b minus 3a. So that is going to be my answer. Let's come down here now. Let's see if we can do these ones a bit faster. So I have 10uv, and I have minus TVU. Now they're the same thing. Pro numerals are in different order, but they're still the same. So if I was to add these together, I'm going to get 8UV, and then I have 3U and plus 7U, which is going to be plus 10U, and then I have 2V, and that 2V doesn't have any like terms. So that is going to be my answer. Very good. Let's now come over here and do our very last one. So I have 5, I have plus 12, I have minus 2. So for this one, I might just write them down so I don't get confused here. So they're all my constants which I can gather together. Then I have plus 4b, and that doesn't have any like terms. And I have negative 3a, which also doesn't have any like terms. And if I was to join these together, what I'm going to end up with is 15 plus 4b. 4b, is it the same as the one I did up there? It is. Is it? No, it's a little bit different. They're just, the numbers are in different orders. That's right. 15 plus 4, what was I doing? I got confused there. It is 15 plus 4b minus 3a. So that is the same answer as I got up here, but they're just ordered in a different way. But that's all right. We still used our same techniques to get the answer that we needed. So with that being said, hopefully you found this video useful about collecting like terms, and I will see you in the next lesson.